our webinar today. This is Gerry Gebel from Axiomatics. Our topic for this webinar is getting the OWASP Top 10 right with ABAC and XACML. So as usual for our webinars, your lines are muted centrally, so we have good audio quality. We are recording this session, so you can play it back later or share it with colleagues. The slides also will be available for download, and there's some extra bonus material, a white paper, and some code samples, which is different for this particular webinar. And then we hope to have time at the end for some questions and answers. And you can use the GoToWebinar question box to enter them, and you can do that at any time, and we'll pick those up later. So our speakers today, joining me is our special guest, Gunnar Peterson, who's quite a well-known security consultant, and you probably have heard of him before. He does a lot of work with different OWASP chapters around the country and even maybe around the world. Where are you calling in from today, Gunnar?
I'm coming in from the upper Midwest today, Gerry.
All right. I'm from warm and sunny New York City today. And we're also joined by Srijis Nair, product manager based out of Amsterdam. And Srijis was the co-author of the white paper I mentioned, and he's here in case we get ourselves into any technical trouble and also add some additional commentary. So welcome, Srijis.
Hi, everyone. Hi, Gerry.
Okay, so what's our agenda today? Well, we're going to talk about the OWASP Top 10, what that is all about, go through a few of those examples, both in PowerPoint format as well as some live demos, and talk about how we can address some of the security issues in the OWASP Top 10 with more efficient authorization. And of course, as I mentioned earlier, some time at the end for questions from the audience. And at this stage, Gunnar, I'm going to turn it over to you to give us the introductory run-through and let you take it from here.
Hey, thanks, Gerry, and thanks for having me. I really enjoyed working on the paper and the code and design applications that we put together with yourself and Srijis. And we've already, I think the paper's been out for, what, about a week or so? Does that sound about right?
Just about, yep.
We've already got some really good feedback on it, and I'll make my plea for questions here from the folks on the webinar. Please post your questions to the webinar control panel there. You can send them to our Twitter handles that Gerry just showed. Gerry may be good enough, or Sujit may be good enough to pick them up in line. I probably won't be able to see the Twitter questions until later. But post them to the webinar if you can. And the reason I bring that up is this is really a different kind of paper and a different kind of presentation. XACML and ABAC, which we're going to get into what those are in a fair amount of detail, have been around for a while as a concept. But what we're talking about here today is using improved authorization to actually deal with common application security threats and vulnerabilities. And so we're not really prescribing this as a solution for the next 10 years as much as we're saying there's a lot of latent capacity that you have in access control technology to deal with a long set of application security vulnerabilities. These application security vulnerabilities, you can get these lists that are as long as your arm or as long as your leg that you have to deal with. It can feel like it's never ending, so it would be good to get more mileage out of the solutions we already have, the technologies we already have, and authorization technologies, frankly, in my opinion, are very underutilized beyond just standard access control. They can absolutely deal with defensive security architecture and zeroing out threats. So why this matters and why identity matters, my buddy Rich Mobo, way back in 2004, which I mean, I don't know if anybody can even remember back that far ago. Who was president? I don't remember. He said corporate networks are like candy bars, hard on the outside, soft and chewy on the inside. I mean, I've heard that quoted probably once a month, every month for 10 years now. And it was sort of apparent then that that might not be quite good enough, and it sure as heck is apparent now that it's not quite good enough. So this crunchy outside, chewy inside, well, bad news, I think everybody here knows that people are getting around the outside, and once they do, there's really nothing on the inside. So this concept of defense in depth, people talk about it. Do people actually build, design, deploy around it? Not as much. So getting more depth into your security architecture, thinking beyond just sort of the initial line of defense to maybe a second and a third line of defense is really critical to having a stronger overall approach to security architecture. So David Morton, and this is an interesting Twitter exchange from last fall, which I really like. David Morton pointed out that we've heard about buffer overflows as a software security problem forever. That's been sort of the poster child for security threats, and now we don't worry about them quite so much because we have things like Java, virtual machines, but we've backed into things like race conditions. And Marinas made an excellent point, which is credentials are the new 0 days. If you think about a 0-day attack, an O-day attack, when somebody has a specific vulnerability against a Microsoft platform or Java platform, and they can use it to get a kill shot against your platform, that's every defender's nightmare. But what about the user? If your credentials are stolen, your session token, your password, your login credentials, that's a 0-day from a user perspective, and just as bad actually. So the fact that the perimeter of the firewall and SSL kind of security architecture is really not getting the job done at making the hard outside as hard as we thought means we also have to pay more attention to the chewy inside and making sure that the rest of the security architecture is as robust as it can be. So the next thing I'd like to go through is the OWASP Top 10, and I'm not going to go through it in a ton of detail. I don't know, Gerry, if you can advance the slide, but it doesn't seem to be advancing for me.
It has advanced now. It might just be my slow connection.
Oh, okay. The OWASP Top 10 is kind of interesting. It's been around for almost 15 years now, and it doesn't necessarily change that much from one year to the next. And it's not because the OWASP team is lazy and sitting on their butts and not wanting to do anything. And it's not that there aren't new attacks. It's that we're frankly not very good at closing out the old attacks. So it's not that that there are all these new attacks that we can't keep up with. There are. It's also the fact that they're sort of new attacks based on old problems. And the old problems are on the top 10 list, and they never seem to totally get fixed. And I think what's interesting is if you class the kinds of threats and vulnerabilities you see in the OWASP Top 10, you have things that rely on malicious code, things like SQL injection, things like cross-site scripting, where attackers will find ways into the system by using the data plane to send commands to the back end, like in the case of SQL injection. And so it's really a failure of safe coding or defensive coding. But then if you step back from it, I would say there's 5 of the top 10, which, I don't have a PhD in math. That sounds like 50% to me. 5 of the top 10 are directly related to identity, access control, and authorization. Broken authentication and session management happens when access keys are compromised and used to subvert the access control protocol. Insecure direct object reference, we'll look at a couple of examples of this today, where the attacker can gain direct access to back-end resources and plow through your database, your web services, your message queues. Security misconfiguration, missing function level access control where authorization code is not in place and you're just relying on security by obscurity. That is the chewy center. I mean, that is the center of the Jolly Rancher. Well, nobody could get by the front end, but if they do, it's sort of game over. And then cross-site request forgery. The application doesn't have fine-grained access control, and a malicious third party can sort of drive a victim's browser to access functionality up on the site using that user's credentials. So again, a failure of authorization. So if you look at each one of these and really look at, well, what's the failure? What did the defenders not get right to allow these attacks to succeed? You can trace that directly back to identity and authorization kinds of failures. And so you can't think about dealing with the OWASP Top 10 strictly as a compliance checkbox exercise, strictly as I'm going to buy a WAF and all of these problems will magically go away, strictly as I can run a scanning tool and run some scanner and that will just magically find all these things. You're certainly not going to find that a WAF will deal with all of your authorization. You're not going to find that a scanning tool even understands your business logic, much less can tell you if your authorization is done in accordance with your policy and makes sense from a security perspective. So these are all issues in the OWASP Top 10 that directly relate to the topics we're going to talk about today. As I mentioned and Gerry mentioned earlier, there's a white paper and there's a lot of code up on the Axiomatics site that goes into a lot more detail than we're going to go into today. You can run the code on your own machines and extend it and build with it and have fun with it. As I said at the beginning, this is a new kind of paper, so it's not that we're prescribing a solution. We're more giving ideas on how you can use existing technologies and get more mileage out of it. I'd also add that all of the labs we're going to show here use the standard WebGoat code that we've extended, and would like to thank the authors of WebGoat and the contributors of OWASP, Jeff Williams, Sharice Kusa, and others who put a lot of work and effort into WebGoat and make it a great learning environment and teaching tool. So we hope to do it justice here today and make it useful for sketching out these concepts that we're going to talk about. So hopefully most people are familiar with WebGoat on the call here today. I'm not going to spend a ton of time talking about what it is. If you have a question, post it to the window. The most basic example, just about the most basic example, is the first one we're going to go into, using an access control matrix. So we've got a set of users, Larry, Mo, Curly, that are trying to access some resources on the site. I think I skipped ahead too far. So Mo is selecting the resource public share and checks the access on that, and Mo was allowed to access the resource on the public share because it's public. That looks like it's okay. And I seem to have lost the clicker. Gerry, can you go to slide 11?
Sure. Now we're on slide 11.
Oh, okay. So the thing that we're trying to avoid is Larry is not in the role account manager. However, in this particular example, Larry selects the resource account manager, and when we check access, he actually does have not just user-level access and public-level access. He has manager-level access and can see the account manager resources. So this is a failure of an access control matrix. You know, I always say when I teach these classes, you know, people will say, well, gee, that's stupid. How could somebody make that mistake? I will say that people say that about almost every lab in WebGoat. And I would also say that I've seen examples of things like this of every single thing we're going to talk about in the WebGoat examples today. I've seen them in the wild. These kind of things absolutely happen in the wild. Sometimes people, you know, sometimes it's a sin of omission, sometimes it's a sin of commission. Sometimes people think it doesn't apply to them and they don't have to worry about it, or sometimes we say, well, why would Larry even select that if he's not even in that role? These kind of things happen all the time, and as an industry as a whole, we have to get better about finding these vulnerabilities, you know, drilling down and fixing these vulnerabilities. So the WebGoat lab is a great illustration of the beginning, the most basic access control matrix kind of failure. They're going to lead you in the solutions of the WebGoat labs into the direction of using role-based access control as one of the ways to solve this problem. And roles are a good way to solve this particular problem. However, they're also somewhat limited in how far you can take them. So we're going to look at, Gerry's going to do an intro on attribute-based access control to go through some more interesting fine-grained approaches to solving this particular problem. Gerry?
Nope, that's good. Sorry to interrupt. But you should have control now so you can advance them.
Oh, okay.
There
yeah, I think that's all I have, so I think it's back to you.
Okay. Thank you. Yeah, so we've thrown around this acronym, XICML or XACML, the Extensible Access Control Markup Language. So this is a little interlude to tell you what this is about. It is an example of attribute-based access control, or ABAC, which is a fairly popular term these days. XACML is an example of an ABAC model because it uses attributes in its policy language and in its evaluation. The standard is managed by OASIS, and you can see here that it has been around for quite a while, but the latest version, version 3, was approved now just over 2 years ago. And the XACML core is expressed really as a document, a PDF document, and there's an XML schema associated with it, and here's the link if you want to go read up in more detail about it. So what's really in here? Well, there's really 3 different things if you look at XACML from a high level. One is a reference architecture, which we'll go through next. The second is the policy language itself that I mentioned earlier. And then a request response scheme, and this is how applications interact with the authorization service to get a decision back from the authorization system. So that represents the core of the XACML standard. And then there are a number of profiles that extend or add functionality. 2 of the more recent ones are the REST and JSON profile. Historically, XACML, of course, it's an XML representation and language format. And the request response historically would also be in XML encoding over SOAP and web services. But now with JSON, you can do JSON encoding of those request messages, get a JSON message back, and you can float that over a REST interface. So it's much more lightweight in that format than in the past. So I think that's quite an advancement and should appeal to this audience. And then as is listed here, there are a number of other profiles that extend functionality. So if we look at the overall architecture, this is not unique to XACML. These acronyms, PEP, PDP, and so on, have been used elsewhere. XACML just picked them up and repurposed them. If you think about web access management tools like a CA SiteFinder, now called CA Single Sign-On, they also follow a similar kind of format in most respects. So if we walk through this, you have the different components of the policy enforcement point. That's the piece of code that intercepts the flow. And this is the piece of code that actually is in the WebGoat sample, right? So this is where we call outside to a service that's labeled PDP, the policy decision point, for a decision about whether a request can be authorized or approved or not. That PDP module has connections to other attribute sources. That's labeled this PIP box here, policy information point. So this can be additional information about Larry, Moe, and Curly. Are they a manager or not? So we can look into a database or directory to find out that information. The PRP box here, the policy retrieval point, that just indicates where the policies are stored. That sort of thing is product specific. And then at the bottom here, the PAP, or policy administration, this is the set of tools you would use to author policies and manage their operational life cycle. In next slide, we'd sort of walk through a typical flow. So you have some user that's trying to access a particular document or a resource or trying to execute a transaction. This is where that policy enforcement point code stops the flow and submits this standard-based message to the PDP or the authorization service can Alice access this document, and it has its policies in memory, but now we need to look up maybe the user role, her clearance level, and the document classification. We analyze all that data, and now we can return, in this case, permit, and we allow the flow to continue. So a pretty simple model for application kind of resources in the web tier, web services, APIs, and the like. And we've also adopted this capability even to databases, applying it to a SQL flow. So a little bit more about the policy language. Now it's really all about attributes, right? We start out with more of an English language statement that says, an analyst wants to view market data related to a new share issue by a secure channel. So our policies are based on these attributes that are highlighted in blue, and they fall into different categories. That is the subject, which can be a human user or machine user, non-person entity, the action, which is specific to the particular application, view, update, transfer, delete, so on, typical CRUD kind of actions are typically used. The resource itself, a document, a transaction, client record. And then environment is more of a general category. It can be things like time of day, device type, is it your own device or a company-issued device, and so on. So all those things, all those attributes go into the various policies and rules to define the parameters for access to resources. Okay, and then quickly about the request response scheme. So again, we have all these attributes in these different categories. They are incorporated into the sets of policies that are deployed. Then you have some application. In this case, it's WebGoat, and we have information from the session and the attempted access, right? Those attributes are packaged up into a message and sent off to the decision service. It evaluates those policies, and you get back the response. Is that a permit or deny? So that's the basic flow that's happening behind the scenes here when we go through the live demo. And I think, Gunnar, we're going to go through a couple more of these scenarios, and then we'll switch to demo mode. Is that right?
Whatever the best way to do it is, either way.
Yeah, I think we can do that. Then we're not switching the screen back and
Sure.
forth so much.
Okay, sounds great. So like Gerry said, we'll go through 2 or 3 other vulnerabilities and sort of get the problem statement right, and then we will look at different ways to address it with ABAC and other code running on the Axiomatics. So JSON injection is a good example of a failure that sort of straddles the line between access control and just malicious use problem. So, I often say that access control is really there to help people who work for us or work with us, customers, partners, employees, to do the right thing. So if you think about your access control scheme, it's really there to help people get their jobs done in accordance with policy. But then we also have defensive services, which are how do we keep the bad guys out. So, security is an interesting business because we have to let the bad guys, keep the bad guys out and let the good guys do their work. JSON injection is an example of a bad guy kind of problem. So we have the fictional scenario of somebody booking a trip from Boston to Seattle. Full disclosure, this was done before the New England Seattle Super Bowl. But this is a JSON-based application, and the price should be $600, I believe, to fly from Boston to Seattle. However, the attacker is going to inject code and get the flight for a much lower price, whatever they choose. So the attacker is going to take that nonstop $600 flight that comes back and change the price from $600 to $1. And that $1 price is going to be in this case, unfortunately for the airline, accepted by the server. So this is just using WebScarab, which is another tool from OWASP. However, you could use any kind of proxy tool that you like here, and that variable price to submit, change it from $600 to $1, send it back to the server, and unfortunately in this case the server does not actually validate that data when it comes back. It just accepts whatever is sent by the user. So again, this is something that is a mistake on the programming side. It's not something that classically fits into a classic authorization use case. At the same time, as Gerry showed, between the policy enforcement point and policy decision point, an attribute-based access control system is actually in the ideal location to act as a filter for certain business logic and other kinds of policies that can step outside of the classic access control stance and look at addressing malicious code like JSON injection and frankly other injection attacks. The next one we're going to look at is bypass path-based access control. As mentioned earlier, these are all in the paper in more detail, and we'll have links at the end to download the code that you can run against WebGoat to test it out yourself and play. So bypass path-based access control scheme is another lab in the WebGoat training tool. And in this case, the attacker takes a file name. The application has a set of files, and you can click bufferoverflow.html or challengescreen.html, select any of these names, and the direct object reference problem that we're looking at here is brought on by the fact that the actual same name of the resource on the back end is what is published on the front end. So these actually map to physical files, physical resources on the back end, and you see this in many, many applications that have PDFs or other things to download. What the vulnerability ends up being in this particular case is that the attacker can actually use, again, a proxy tool like WebScarab and change the name of the file from, in this case, client-side filtering.html, to a different file, and in this case, a different location. In this case, we're going to traverse the file system and go up to the root directory through a series of .. and get up to /etc/password and have the entire password file downloaded to the attacker through the browser. So again, this is just a simple example where the direct access to the resource on the back end name is published on the front end, and that access doesn't ever go through either an access check or any kind of authorization check. It's just passed through directly to the server, and so we're going to see a couple of pretty interesting examples on how ABAC can help to address that. And our last example is forced browsing. Forced browsing is something that you often see if you read into the headlines or past the headlines into some of the breaches that you see in the newspaper. A number of them end up coming back to things like forced browsing, where attackers are increasingly going after higher privileged accounts, admin kind of accounts, through waterhole attacks or other kinds of attacks where they know that the victim may have higher privilege access, but is able to be pulled in by an email or by another website to actually run code back up against a configuration site, an administrator site, and so on. So in this case, in the forced browsing case, the attacker is going to just point the victim's browser to a configuration page and give the attacker the ability to get access to set admin privileges, set admin passwords. So Again, this is a case where the victim's browser is redirected and forced to browse to a location that they did not know. And this kind of attack can be hidden inside of hidden fields, inside of hidden frames, redirected to the point where the user doesn't even know it's happening. WebGov makes the attacks very, very noisy, so you can learn from them. However, in the real world, they would be silent. So those are the 4 examples we're going to talk about here. We also have a 5th example in the paper on parameter tampering, so be sure to download that and run that one. But again, in all of these cases, Gerry and Surjit are going to show in their demo how these kind of malicious code attacks where the attacker is subverting the access control in the system the ABAC policy enforcement point and policy decision point are in really the ideal location to defend against them. Policy enforcement point has the structure to recognize what looks like good traffic or bad traffic, or good requests or bad requests. And the policy decision point has the logic that can map what behavior should be allowed or not allowed. So those are 2 very powerful tools that can be extended well beyond just standard access control use cases. Gerry, I'll hand it back over to you to run through the demos, which I'm sure everybody is on the edge of their seats to see some code.
Great. Thanks for that setup. Can you hear me okay again, Gunnar?
Yeah, but you can yell a little bit louder.
Okay. We'll try to do that.
That's great.
Okay. Well, the first example was the access control matrix situation. So here, I'm going to click on using an access control matrix, and this is where I have Surjit on standby in case I do something incorrect here. Now, what you showed in the screenshots was the user Larry trying to attempt to access an account manager resource. And you said he's not authorized to do that, right, Gunnar?
It shouldn't be, yeah.
Right. Now, in this system, you can see I've got a VM running here, and what we have is the actual WebGoat application. And then behind the scenes, we've got the Axiomatics policy server implementing the XACML and ABAC rules. So in this case, we're going to do the check access, and voila, you can see the error message that comes here that Larry does not have the privilege to access the resource account manager. So we have a rule in place that specifies when it is permitted, and we actually look up whether Larry has the admin privilege or not, or the admin attribute assigned to him or not.
And all I would say there is you got to love any kind of middleware demo, especially middleware access control demo, is only security people can get excited about. Oh, and look, this did not happen. So that's always the fun part about these demos.
Right, right. Almost like a single sign-on demo, right?
Yes.
Okay. The next one, or anything else you wanted to add to that, Surjit? Any other comment?
Now, I guess the only thing I would mention there is if you look at the code, we kind of hard code the access control matrix in the example code itself, and we pass in our actual demo, we pass the role of Larry in this case as a part of the request to the decision engine. While you can always not do that, you can just pass the username of Larry and then let the PDP look up Larry's role from LDAP directory or a SQL or an attribute dictionary from somewhere where the role is defined or mapped, and let the PDP do that extra work. It's just a different way of doing it. We just done it in a more compact manner.
Sir, can I ask you a question? On Gerry talked about the policy enforcement point and the policy decision point. If I was going to add this to my hypothetical WebGoat application back at the company I work at, what do I get? What gets embedded into the web application? What gets embedded into this lesson plan effectively, and what's externalized?
Right. So in a typical setup, what you would do is all the policies which decides who or which role can access which resource or which classification of resources would be externalized into the policy decision engine. So all your authorization rules and policies gets externalized, while what the web code app itself would give to the PDP is the information it has, which is who is trying to access, so in this case Larry, and what is he trying to access, in this case account manager resource. That's sent over to the PDP, and the PDP gives you back a permitted or deny. Now the good point of that is, because you're externalizing authorization, which is more of a business logic or a business rule, every time you change that logic because of compliance needs or business needs, you don't have to go into the app and change the logic that you have kind of hard-coded in the application. You just change it at the policy side, leaving the app alone for a very long time.
Yeah, and I guess the other part I like about it is, if I'm the security person, and I have 100 developers and I have like 3 security people, I don't have time to go and write 10,000 lines of code for every single application, because I only have 3 people to do it. And I think the example that we have here is for the policy enforcement point. It's only a few lines of code to get the policy enforcement point in line in the application. So my actual, touch point into the application to embed the PDP is pretty minimal and pretty lightweight. Fair?
Yep, I agree.
All right, let's carry on with the next example. This was, what was it? It was a JSON injection.
Yep.
So we'll go to this section here. This was reserving the airline ticket. So I forget what tool you used, Gunnar, but we have a tool called tamper data, so that we can intercept the flow and change that price, as you were saying. So we're going to go from Boston to Seattle, and when we hit submit, this is when the tamper window will come up. And did we not start it? I think I need to start it. That's what I did wrong. Okay, I started the tamper. We'll go back here. Go to Boston, from Boston to Seattle.
It takes practice to be a good bad guy, Gerry.
It does, especially when you're typing one-handed here and holding the phone. So here's where the tamper window comes up. Yes, we do want to tamper. Do I do submit or tamper?
Tamper.
Okay. And do OK there. Okay, now I select, I want to go direct Boston to Seattle. Hit submit. Yes, I want to tamper. And here is where I can change the price. So this %24 is just the $sign. But here's where I'm going to get it really cheap. I'm going to get it for $1. Change it, and it's, wow, it was stopped. Not like in your demo, Gunnar, like in your screenshot. So here we attempted to change the policy, but this goes back to validating the inputs, right, Gunnar and Sridhar?
Goes back to validating the inputs, and it goes back to making sure that your access control policy enforcement point has the ability to get as granular as something like a price. That's, to me, the big lesson that I take away from here, is that you have to have access control down to the bits of data, the attributes that are as sensitive, that are the assets, the sensitive assets in the system. What are your thoughts, Sergey?
Yeah, exactly that point. The fact that you have the PEP and the PDP kind of positioned in the right place, as Gunnar, you mentioned, to do this interception, it kind of helps you reuse an existing architecture and the setup, so you can offload a lot of the work that you would otherwise have to do on your app side to the existing infrastructure, so that it takes away the burden of the most of the work and externalizes the authorization system. And as you mentioned, Gunnar, the fact that you can go as fine-grained as what can be changed from the client side and what can only be changed from the server side kind of shows the the flexibility of the ABAC system in general to kind of adapt to your authorization and security needs.
Okay, let's go to the third example. This is, well, I need to turn this off for now, Shrujit, I think.
Yeah, you can actually stop filtering. Yeah, stop tampering.
For the moment.
Yeah.
So we're going to bypass do the bypass back path example. So we go into access control flaws.
Gerry, if you can go a bit slow, because I think the screen is sometimes catching up with you, so because of the lag. So if you take a bit slow, then hopefully people can see you talk and see the screen at the same time.
Okay, fair enough. Apologize for any delay there. So again, we're doing the bypass path here.
Mm-hmm.
So we'll select that option from the left menu. And this is where we're going to select a file here from this list. Doesn't matter which file, because again, we're going to try to change it.
And then you tamper before you submit.
Right. So this time I'll try to remember to turn on the tamper.
Yeah.
And start. Okay. Go back to our web page. And I'll click on View File. Do we want to tamper? Yes.
Yep.
And tell me again which window I put the...
I think it's if you can just wait for the screen to kind of load and get to the point that that you're talking about. So I'm seeing still, yeah. So if you look at the file, the top right-hand corner, there's a form field called file, and you change that to // main.jsp or something like that.
Right. So I'm trying to maneuver out of one of the files in the drop-down window and go to a different source or a different location.
Yeah, up the directory structure. So basically, you can go traverse all the way up to etc password or something like that, which is what Gunnar did.
Right. And did my screen refresh for you now, Sturgis?
Yeah, it
so
did.
Now you see the error message that's been displayed here, that while the application was going to allow me to enter that new location, an XACML policy denied it. So can you explain more about what happened there behind the scenes?
Sure. So in the policy that you would see as a part of the download, what we have is very, very simple. Actually, it's in a way naively simple, because what we have done is, as a proof of concept, write a policy which says you cannot use a file path which starts with .. or you cannot have a .. in your file name. That's a very simple scenario that we have shown, and a very simple way of circumventing, a way of preventing it from happening. And as you will see in the chats that Gunnar and myself had, we were called up on this, basically saying it seems a bit too simplistic, because you can do much more stricter way of enforcing using indirect object reference. And that's something that we will discuss further in the webinar slides itself. But for now, what we have done in the policy is deny access to any file which has got a .. in its path. So it's rude and crude, but it does the job for a very simple POC.
Mm-hmm. Okay. And then we have one more example here. This is the forced browsing example. So we go down to insecure configuration, and we have just one option here, the forced browsing. And we can stop the tampering for now. So has the window refreshed for you, Srijit?
Not yet. If you can just give it a sec.
Yep. Just tell me when it is available.
Yep, we have got that.
Okay, so now I'm going to change the URL here, and I'm going to try to go to the conf file this way.
Again, I guess it's one of those demos where nothing happens if everything happens well. So.
Right. And even here, it's hard to see the error message. Has the screen refreshed for you, Sturgis?
No. So the idea is, yeah, now it has. So even though you try to go to /conf, that access was denied, and what WebGo does in general is to forward you back to the main page again. So that's what you are seeing in Gerry's screen, which is that even after he tried to go to /conf, it forwarded him to the original screen where he came from, because he doesn't have the role of the user doesn't have the ability to go into the maintenance mode, which is what is needed to go to the /conf web page.
Right. Right. Okay. Now that's the end of the demo. Did we want to show the policies as well, Surjit? Or
Yep.
yeah?
If you want, we can, since we have about maybe 2 or 3 minutes, we can quickly go through the policies that we have provided. So what Gerry is going to do is he's going to open up Eclipse, which has got what we call the Axiomatics language for policy authoring, which is alpha. The idea behind that language is that it provides you with a very simple Java, C# like meta language to write heavy SACML policies. Instead of having to write it in XML, you get to write it in a Java, C# like language, which is what you see in the screen. And then Eclipse provides, the Eclipse plugin that the Axiomatics provides then compiles that Java-like language representation into XML files, which are then deployed on the evaluation engine. So if you see in the screen, what you're seeing is a very simple access control matrix, where basically what we have said is, if you want to access a resource called account manager, you have to be an admin. So your role has to be an admin. If you have a site manager, your account has to be something, the admin role again. Time card approval has to be manager. And similarly, performance review, you have to be a manager before you can get to that section. So this is kind of a codification of the implied access control matrix that's part of WebCode. And we just wrote it as an access control matrix policy. And what would then happen is, when Larry was trying to access the account manager resource, his role, which was manager instead of administrator or admin, would be sent to the PDP. So the PDP will evaluate and see, look, it's trying to access a resource called account manager, but his role is only a manager. So you can't be allowed to access that resource, and it sends back a deny to the WebGo web app. And then the PEP side of the web app basically checks, okay, I got a deny, which means he's not allowed access, so he just sends back an error response that can be shown to the user. So if you go down, Gerry, a bit, you will see similar alpha code for all the other 4 examples that we have. And this can be downloaded from the same place that you can get the white paper. It also talks about the same kind of examples we looked at before, the JSON encoding, injection, the path-based access control, and the force browsing. All of them have examples written in alpha, and a corresponding XML file will be generated that you can deploy onto the actual PDP itself. I think that should be good enough, Gerry, for now.
Okay. Thanks for that, Sridhar. And just a further reminder, so Alpha, as you can see here, is designed for developers. It's an Eclipse plugin that's free to download for non-commercial use, so you can get the plugin as well as this source code. And we have other policy editors for other kinds of people, system admins or business analysts, but this one is targeted naturally for developers. All right, so if you go back to the presentation.
I thought when you said other kinds of people, you were going to say security people, because I always like Adam Shostak said security people are from Mars, business people are from Wharton. So I always like that one.
That's so true. Okay, I think, Sridhar, this was what you were talking about earlier, the Twitter exchange here. About the one example, right, the indirect object example. Do we want to go to the next page here?
Yeah, so I think we got called up by Jeff by saying, look, the .. stuff was a bit weak, and of course, indeed, the .. example in the SACML policy that we have provided is just an example to kind of give you an idea of what an XACML policy would look like. But a more elegant solution would be to use the indirect object reference. But because the core reason why the attack happens is because there is a direct mapping between what is shown in the UI and what the user can choose and what is that referencing in the server side. The HTML page and the HTML name would correspond to the exact HTML file on the server side, and that is a direct object reference issue. And of course, the indirect object reference, basically the idea behind that is you create a reference value, an integer, a random character sets, or a UUID that represents the actual object. So instead of letting the user choose the actual name, you just let him choose a value. Of course, you show the user the actual name, but what gets submitted is a value instead. And there are two ways in which then you can use the SACML solution. The minimal use of PDP solution would be where the PDP has a mapping, who can access which indirect reference. So the app basically asks the PDP if the user is allowed to access specific indirect reference. Say, for example, can Larry access reference number 6? Number 6 could be a PDF file, HTML file, and so on. And the PDP just replies back with a permit or a deny, and the app performs the actual reference to object mapping. So the heavy lifting is still done by the app when it comes to the mapping lookup. The app does that while the PDP just sends back a permitted to deny based on the indirect reference. The other another way of handling the same scenario would be for using PDP to perform the full lookup. So add the reference map to an information point, the PIP that you saw in the architecture, and when the PDP gets asked a question whether Larry can access object of indirect reference 6, it sends a permit or a deny as before, but it can also then send the actual mapped object's identity, could it be some PDF file name or something, back to the web app. So the web app doesn't have to do that lookup. The PDP itself can send it back, what we call a SACML obligation. An obligation is a way to tunnel some more information from the PDP back to the PEP. And then what the application, in this case web code, needs to interpret that response and say, okay, what I'm getting back is a deny or a permit. If it's a permit, I need to look into the obligation objects and see what is the mapping resolved to, and give that mapped objects the actual access by Larry. So that's two ways of handling the same scenario in a more complicated manner than just doing a ... example that we have shown in the SACML policy we have provided.
All right, great. Thanks for that, Srijit.
Sure.
And just a few things to wrap up here. Gunnar, did you want to speak to these here to sort of bookend the session?
Sure. Thanks, Gerry. So first off, we've looked at web code examples and web application examples. More or less everything we've looked at applies just as much, if not more so, to web services security, REST security, API security, mobile server-side security. The direct object reference REST web services have this problem in spades. It's a major problem for REST web services. And so we use WebGoat because people are familiar with it, because it's a fantastic learning environment tool, and we really tried to stay true to the spirit of WebGoat as a learning environment. We didn't go and try and define Baroque perfect architectures to make even more perfect. We took real-world inspired applications with real-world vulnerabilities and tried to show exactly how XACML and ABAC can help address those issues and closing out vulnerabilities. So I think what we're really getting at is a fundamentally different approach to access control. Gerry talked about putting together access control policy based on users and what roles they're in and what they're trying to access and what their classification level, and doing those kinds of mapping. That stuff has to happen, and we continue to have to get better at that, and ABAC is a good way forward there. In addition, access control languages like XACML and approaches like ABAC can be used to rule things out. So not just to allow things to happen, but to rule things out. And we're in the right location, the policy enforcement point's in the right location to enforce these policies. We have access to the right attributes to enforce these policies, and we have the ability to code and enforce the logic that we need to deal with JSON injection, forced browsing, direct object reference, and the other vulnerabilities we've had. So it's both access control from a what are you allowed to do, as well as a list of things that you're not allowed to do to protect against pernicious vulnerabilities. We didn't talk a lot about the side benefits of externalizing this logic from the code, but the fact that we were able to go and swap out and make a different approach to the direct object reference problem over the weekend, it's a good example of how you can move and make a lot of progress quite quickly in this approach. And you can make your auditors happy, which is a nice side benefit as well. Again, as we said earlier, all of this code is available. Everything you've seen here, you can download in these code examples, run it on your own, and we'd be definitely interested to hear what works and well for you and how we can improve it going forward. So Gerry, Surjit, I'll turn it back to you and for the close.
Right, very good, Gunnar. Thanks for that. And you see the link here again for downloading the white paper and the code. It looks like we're running up against our time limit here for the Q&A, so we'll invite you certainly to contact us directly if you have any questions. We'd love to get your feedback on this topic. And we just have a reminder of some other events coming up here, a couple of local IAM meetups. Gunnar, I know you participate in the very active one up there in Minneapolis, and I'll be in LA later this week and in Chicago. And these are springing up around the country, so they're a great local resource.
Yeah, just a quick note on that one. I believe I'll be doing a version of this in April for the Twin Cities OWASP conference, so that'll be not too far distant future. But hit us up on Twitter or other places, and we can get other dates on this out to you.
Right. Well, I think we're going to close the webinar there since we're right up against the top of the hour. Gunnar, thanks so much for writing the white paper, for putting together this webinar with us and the samples, and to Surjit for doing the technical side implementation and also providing input and for the paper. It's great to have this content available. And by the way, it's going to be part of a new OWASP cheat sheet in the near future, so please be on the lookout for that. And thanks everyone for attending, and we look forward to seeing you either in person or again here on the next Axiomatics webinar. Thank you very much.